Hello, algebra students. Mr. Laurence here, and this is our second video on, excuse me, solving nonlinear equations. Sometimes they're linear, but we're also solving nonlinear ones. And I want to throw this idea at you that this is called the zero product property. What is called the zero product property? Well, it's the idea that this big multiplication problem here, for it to equal 0, one of its factors must be 0. Right? A product is the answer to a multiplication problem, right? So the zero product property, we're not writing, zero product property tells us that one of the factors must be 0 if the product of a multiplication problem is 0. So we know how to solve each one of these pieces after you saw the video last night and the work we did in class. We know, first of all, let's see, we've got x to the first, and x to the first, x to the first, x to the first, x to the first. If I multiply all those together, I'm going to get an x to the fifth, right? So this is a degree 5 polynomial. It's degree 5, which means it has at most 5 solutions, right? Now, it doesn't have to have 5 solutions. Remember, it could have 4 solutions, 3 solutions, 2 solutions, 1 solution, or no solutions. I think this particular one will have 3 solutions, but it can't have more than 5. So anyway, I take each factor, set it equal to 0. Solve for x. Well, there's one solution right there. X is 0. I'll take x plus 5, set it equal to 0. Subtracting 5 from both sides, and I will get x equals negative 5. Okay, then I take x minus 2, set it equal to 0. Add 2 to both sides. X will equal 2. And I don't need to do it here and here because it would just be repetitions of these two, right? So my solutions are negative 5, 0, and 2. And I got those using the zero product property. I set each one of these equal to 0, each unique one that is. All right, in a minute we're going to come down here and try these. But before we do that, I want to talk about distributing really quick. We've got 3x times the quantity of 2x minus 8. And I know you guys are really getting good at distributing, which is awesome. So 3 times 2 is 6, and x times x is x squared. And then 3 times negative 8 is negative 24. Oops, sorry about that. Said it right, just didn't write it right. Negative 24. And there's an x on the end. Okay. Can you look at, we're going to call this A, B, and C, and they look like the answer to a distribution problem. Can you go backwards? Can you tell me what was distributed? Well, it's really easy to do. For each problem, what you need to find is the greatest common factor. We need to find the GCF of 7x and 14. Well, I could think about 7x as 7 times x, and I could think about 14 as 7 times 2. But what do they have in common? Well, they have a 7. That's the common factor right there. The greatest common factor is 7. So I could undistribute it. I could pull out the 7, right? And if I pull out the 7, then what's left in the quantity? Well, there'd be an x left because I'm really dividing here. And then I would have a 2 left. And there, I undistributed, right? I took the answer and I went back and made it look like a distribution problem. Now, don't go and then redistribute. You'll be undoing what you just did. All right, let's check out the GCF here on 12x squared and 8x. Well, I know that 12x squared can be thought of as 3 times 4 times x times x. And that negative 8 can be thought of as negative 2 times 4 times x. See, in my head, I'm already figuring out the GCF of 12 and 8, the greatest common factor, so that I can write 12 as 3 times 4 because I know the GCF of the numeric part is going to be 4. Okay, so now let me go and highlight the common factors. So let's see, I've got the 4 I just talked about. It's there and there. And then I've got an x, that's a common factor, right? I notice I didn't highlight both x's because there's not 2 x's being multiplied here. So my GCF looks like it's going to be 4x. So I'm going to factor out the 4x. What's left inside? Well, if I factor out the 4x from here, I'm left with a 3x. 3 times x is 3x, isn't it? And if I factor out the 4x here, I'm left with a negative 2. Oh, that's not so bad. And the way I know I'm done is there's no common factor between 3x and negative 2 besides 1. Okay, 1 is somewhat trivial. All right, let's try it on this one. Okay, I've got 20 and 25. You know, I'm thinking 5 is the numeric part. So I'm going to think of 20 as 4 times 5. And then watch this. I'm not going to write x times, well, maybe I will write x times x times x on this one. I'll show you a trick in a second. Okay, so I don't lose anybody. And then I'm going to think of 25 as negative 5 times 5, and then, of course, x times x. And I'm doing this a little bit of the long way, just because I don't want to lose anybody. And so let's see, I highlight the 5, and this 5 here. And I'm going to highlight this x with that x, and then another x and another x. So what is the GCF of these two numbers? Well, I believe it's going to be 5x squared, because x times x is x squared, right? Okay, what's left if I factor out the 5x squared? Well, I have a 4x left. Okay, and if I factor out the 5x squared here, I have a negative 5 left. And there you go. You just pulled out the GCF. We did a technique called factoring there. Now, before I go back to those other problems, let me throw one at you like this. Let me give you, say, 36x to the 5th minus 27x cubed. And I'm lazy. I don't want to do more work than I have to. I do enough work as it is. So whenever I work smart, I appreciate it because it frees me up to be able to do other things. Well, first I'm going to look for the GCF of 36 and 27. I'm pretty sure it's 9, okay? If you didn't know, you could, 27, list the factors of the one with the least number of factors, 9. I think that's it. Yeah. Okay. And then you can see, does 27 go into 36 evenly? Nope. Does 9 go into 36? Yep. It must be the greatest common factor. Okay. And this is an old skill that you should have mastered already. If you need some practice with it, please come and see me. All right. So I'm going to think of 36 as 4 times 9. And 27 as 3 times 9. I guess there's a negative there. Now, I'm not going to think about the x to the 5th as x times x times x times x times x. I'm going to cheat. And I see an x cubed over here. I'm going to think about x to the 5th as x cubed times x squared. You kind of know how to do that, right? There's 3 x's and there's 2 more x's. They're all being multiplied. So that's how I'm breaking up x to the 5th, okay? X cubed, then I can just write as x cubed. All right, so let's get our highlighter out here. And so the numeric part, there's a 9, that's a common factor. And there's also an x cubed, that's a common factor. And so my GCF ends up being 9x cubed. Now if I pull a 9x cubed out, what am I left with? Well, 4 times x squared, 4x squared. I pull a 9x cubed out, I'm left with a negative 3. It's really pretty easy. You've got to know your multiplication facts for it to be as easy as I'm making it. Let's try one more. Let's go with 48x squared minus, let's go with 20x to the 4th. Okay, so looking for the greatest common factor of 48 and 20. Well, I'm going to list the factors of 20. Okay, 2 and 10, 4 and 5. And notice I list them in order. They kind of converge toward a middle. This way I don't miss any. First of all, does 20 go into 48 evenly? Nope, it doesn't. Does 10 go into 48 evenly? No, I don't believe it does. 5 into 48? Nope, not evenly. 4 is my GCF. So I'm going to think about 48 as 4 times 12. Okay, I'm going to think about 20 as negative 5 times 4. I didn't use a negative 4 because I'm getting a positive 4 as my GCF. Okay, now I'm going to look at the smaller of the two exponents, and that's what I'm going to write down here, x squared. But then here, this is going to be x squared times x squared, right? See how I did that? I broke x to the fourth down into two factors. I could have broke it down in x to the fourth times 1. Could have broke it down into x cubed times x. X squared times x squared. Okay, of course I could have done this one, but it would have been redundant, right? So I chose to write it like this. Why? Because the greatest exponent on the other x term was x squared. All right, so now I'm going to go and highlight my common factors. So let's see, I have a 4 and a 4. I have an x squared and an x squared. So I'm going to factor out a 4x squared. That is my GCF. If I factor out a 4x squared, I'm left with a 12. And then negative 5 times x squared. Well, that would be a negative 5x squared. Okay, now that you see how we do this, let's see if we can use it to help us solve an equation. Now, this is a quadratic equation. At most, it can have two solutions. Let's see. Oops, I didn't make that equal to 0 over there. Sorry. Let's see if we can factor out a common factor, the greatest common factor, and then it'll be equal to 0, and then use the zero product property to solve. So I'm thinking the GCF of the numbers is 5, right? So I'm going to think about this as 5 times 2. And the highest power of x is x to the first, so I'm going to think about x squared as x times x. And this will be thought of as negative 5x times x. Okay? Get out my highlighters. Now you got to be careful with this one. I've got a 5 that's common, and a 5 that's common there. I got an x, and I've got an x. Got to be careful. I'm warning you, Kevin. You paying attention to this? My GCF is going to be 5x. So I'm going to pull a 5x out. What's going to be left here? Well, 2 times x, or 2x. What's going to be left here? The danger is some of you are going to say 0. But remember, if distribution is multiplying, if we're going the other way, this must be division. So there's not a nothing there. There's a 1. 5x divided by 5x is 1. Okay? Set it equal to 0. Now I can use the zero product property. I can take each of the factors, set them equal to 0, and then solve. So I'll divide by 5, x will equal 0. And then add 1 over here, and I'll get 2x equals 1. Divide by 2, x will equal 1/2. And so your solution set for this one ends up being 0, 1/2, like that. Those are the two numbers that make this equation true. That's what we just found. All right, let's try to do this one here. And we are going to look for the GCF of 3 and 12. Well, I'm thinking it's 3. Okay. And the highest power of x is to the first. So I'm going to think about x cubed as x to the first times x squared. Getting my highlighters out so that I can find my GCF. Notice I was careful not to factor, or not to highlight the negative. There's an x to the first and an x to the first over there. And so it looks like my GCF is 3x. So I'll pull a 3x out. I'll be left with an x squared and a minus 4 equals 0. Using the zero product property, I'll get 3x equals 0. I'll divide by 3. x will equal 0. And then I'll have an x squared minus 4 equal to 0. I'm going to go ahead and add 4 to both sides. Normally I wouldn't do a quadratic this way, but for right now I think it'll be okay. And then I'm going to take the square root of each side. Now you got to be careful here, because a lot of you are going to argue with me and tell me the answer is 2. And I don't totally agree with you. You think the answer is 2 because 2 times 2 equals 4. But I know another number I can multiply by itself and still get 4. That would be negative 2 times negative 2, wouldn't it? So you see, the answers are 2 and negative 2. So the solution set would be 0. Oh, hold on a second. Let me write them in order, ascending order. So the solution set will be negative 2, 0, and positive 2. And so there are 3 solutions. And look, it was cubic. So it's okay that there were 3 solutions. All right. One more here. And this one's kind of strange. Okay. Now, I'm going to go ahead and subtract this from both sides so that I can set it equal to 0. And like I said, this one's kind of strange. So I'm going to rewrite the x minus 2 as a quantity and the 2x minus 3 as a quantity. And then I mentioned I'm going to subtract that from both sides. So I have to put it over there. And I'm going to clone it one more time. And so it'll end up looking like this. And then we'll have equal 0, right? Because these would cancel each other out. And I have these 2 quantities minus those 2. Now look really carefully at the problem in red. The part of the problem that's in red is a multiplication problem, right? A double distribution. And there are 2 factors. There's the factor x minus 2. And then there's also the factor of 2x minus 3. Now, the green part of the problem is also a multiplication problem. And there I have a quantity of x plus 5. And I also have a quantity of x minus 2, don't I? Yeah, I sure do. So, I can pull out this common factor. Just like I pulled out the common factor before, I can think of this x minus 2 quantity as having been distributed. So the GCF of these two is the quantity of x minus 2. I'm going to pull it out front. Well, what's left inside? Well, if I pull that out, there's a 2x minus 3 inside. And then I pull out this, and I have negative of x plus 5. Like that, right? Okay, I know this is kind of a weird one. All right, so we're going to have x minus 2, and then we're going to distribute this negative here. Okay, we'll have 2x minus 3 minus x minus 5 equal to 0. I'm going to simplify that quantity a little bit by combining like terms, and then I'll be ready to use my 0 product property. So I have a 2x and a negative x, and I also have a negative 3 and a negative 5. So I'm going to have the quantity of x minus 2 times the quantity of x, the yellow ones turn into x, minus 8. Set it equal to 0. Now I'm going to use 0 product property. X minus 2 equals 0. X minus 8 equals 0. All right, so I solve this, I'll get x equals 2. If I solve that, I'll get x equals 8. My solution set is 2 and 8, just like that. All right, let's have a video quiz now. We're going to wrap this up. This is taking a long time. So here comes your video quiz. Not that you can see it at the moment. Oh dear, we've got a dancing highlighter or pen. So your video quiz is 2 problems. 1, I want you to identify if it's linear, cubic, quadratic, quartic, degree 5, whatever the case may be. Sorry, that's supposed to be a 2. I'm getting very tired. I apologize. All right, 2x minus 5 equals 0. And then solve. Look, see if there how many solutions there are. The second problem is I want you to undistribute on this problem. So 36x to the fifth minus, let's go with 16x to the sixth. Okay, don't have to solve it, just have to undistribute to make it look like a distribution problem using the greatest common factor. All right, Mr. Lawrence signing off. Have a good night, everybody.